So we're looking at 4.4, which is Introduction to Trig Equations. So we're looking at solving equations. Realistically, when you solve equations, you're looking for a value of a variable. Our variable that we're going to be looking for is theta. Lots of times people put it as an x or other things, but as we get further and further up in math classes, we use this theta angle measure. In general, we usually solve over a given domain. So they give us some x values that they want us to solve for. Lots of times it's between 0 and 2 pi, 0 and 360, whatever the domain is given in. So if the domain is given in radians, your answers should be given in radians. If your domain is given in degrees, your answers should be given in degrees. Okay? When we take a look at some of this stuff, when they write sine squared theta, it's really like sine theta all squared. So you can take the square root and get rid of it. Let's look at a couple examples. So it's just like trying to get x alone. So, but that x is theta. So we got to start moving things with theta to one side and the numbers to the other. So I'm going to add the 3 cos theta to both sides and subtract the 5. So that gives me 10 cos theta equal to -3. Divide by 10, cos theta is equal to -3/10. And then I actually have to solve for theta. So to get theta alone, we use cos to the -1 of that value. If I actually go about and do that, and this one solves into the nearest 10th of degree, when I pull up my graphing calculator, I want to make sure, because I'm going from 0 to 360, I need to make sure that my calculator is in degrees. If I was going from 0 to 2 pi, I need to make sure that I'm dealing in radians. So right here, I'm in degrees, so that's great. Second quit, coming back here, if I'm going the cos to the -1 of -3/10, or -0.3 by whatever, gives me 107.5. So theta equals 107.5. Now, when we solve, this solves for cos from 0 to 180 degrees. So when we draw this diagram, it actually ends up 107 degrees. When we think about it, we've got the cast rule. We had a negative cos. Where's cos negative? Here and here it's negative. So really that 107.5 falls in here. Now that's positive from this 0 line. So that's one of our answers from 0 to 360. But we've got to figure out, how do we get from the 0 line to here? What is that line? Well, we've got to remember that this 107.5 can follow it this way, because this is 107.5 just by looking at the angle. So that's actually 360 minus 107.5, borrow the 5, borrow the 1. We get 252.5. So our two angle measures are 107.5 and 252.5. Realistically, if we wanted to double check, we could take the cos of those two angle measures, and when we did so, we should end up with -3/10. Or you can take both angle measures and come back up in here and put theta as 107.5 in both spots. We should end up with some equal signs that'll equal on both sides. That's a way of checking. So, example 2. Let's solve for theta from 0 to 2 pi. So here we're dealing with radian measures. Give our answer in exact form. Exact form means no decimals that run on forever. Usually we like to use the unit circle if we can. It makes life easy. Same thing, we got to get theta alone, so I'm going to subtract the 6 cotangent. So 7 minus 6 is just 1 cotangent theta. I'm going to add the 4, gives me -1. Cotangent theta to the -1, that's a reciprocal. Its reciprocal is tangent. So I'll do tan theta is equal to -1. If we do the reciprocal, that's also -1. Where is tan -1? Well, if we look at our cast rule, tan is negative in this quadrant and in this quadrant down here. We can do a couple things. We can remember that tan is sine over cos. And so how do we get sine over cos? If we look at our unit circle, we get 1 comma 0. We get root 3 over 2 comma 1/2. We get root 2 over 2 comma root 2 over 2. Oh, if I divide sine cos over sine, or sine over cos, the second one over the first one, that gives me 1. So that's at an angle of 45 degrees, or as we remember it as pi quarters. So pi quarters is here, and pi quarters is here. What actual value is that? If we look at our unit circle, that's 1 pi quarter, 2 pi quarter. This says 3 pi quarters here. And this is 1 pi quarter back. So 3 pi, 4, 5, 6, 7 pi quarters. So our two answers that fulfill this equation is 3 pi quarters and 7 pi quarters. Now, if you wanted to, you could look at your calculator and go second tan of -1. Now, right now, I'm in degrees, so my answer becomes -45, right? So subtract 45 that way, subtract 45 that way, and we get those two answers where tan is negative. If we change our mode into degrees, or into radians, I just want you to see this, because this is radian measure. If we go second tan of -1, it gives us this weird decimal, okay? But if I go pi divided by 4, gives me that same weird decimal. So your calculator gives you radians, but it doesn't give you pi radians, it gives you decimal radians. So it's kind of nice just to be able to do exact values in this sense. It's easier using your unit circle. I don't know how many times I can tell you that. Okay, example 3. Solve theta for the given domain. We're going from 0 to 2 pi, so yet again in radians. Need to get theta alone, so I'm going to divide by 4. So I get cos squared theta equals 3/4. So when I take the square root, I get cos theta is equal to the square root of 3 over 4. When you take the square root of things, that's a plus or minus. So we're looking at lots of answers. Where's cos? Oh, back up. It's the square root of 3/4, right? Woo! So that's actually plus or minus the square root of 3 all over 2, because the square root of 4 is 2. Okay? Now, plus or minus means where's cos positive, where's cos negative? That's all over the place. Where is cos root 3 over 2? Remember, it goes cos comma sine. Right here. It's root 3 over 2, right? So that means this is a pi 6 away. So this is pi 6. This is 5 pi 6. This is still a pi 6 away from the x-axis, right? Is what we got to remember is these are all root 3's over 2. That matches up with your square on the unit circle. So my answer is 7 pi 6's and 11 pi 6's. Okay, so smart trig class. Cos is positive here and here in quadrant 1 and 4, but negative in quadrant 2 and 3. but because we took the square root, it's the plus or minus, so we actually end up with 4 answers. Okay? So theta is equal to pi 6s, or 5 pi 6s, or 7 pi 6s, or 11 pi 6s. Good? So let's look at example 4. The equation tan theta for 0 to 2 pi has 2 solutions, pi quarters and 5 pi quarters. Write the general solution. So the general solution is the all-knowing kind of solution. So when we think about it, it's basically plus or minusing 2 pi. And so we always add or subtract 2 pi n, because n, it stands for a number that's 1, 2, 3, it's a whole number, right? Basically, it just continues to go up and up. So the general solutions are pi quarters plus or minus 2 pi n's and 5 pi quarters plus or minus 2 pi n's. Okay? So you just keep on adding or subtracting 2 pi's to get more solutions as you get further and further away. So that would be expanding your domain. Okay? So here, if we expand our domain from 0 to 4 pi, well, we know this works for 2 pi, the pi quarters and the 5 pi quarters. But in order to go to 4 pi from 2 pi, we have to add 2 pi. So we actually have to take a second and add 2 pi. So it'll be pi quarters plus 2 pi and 5 pi quarters plus 2 pi. But how do you actually add 2 pi? Lots of people think of it as 8 pi quarters. That's what 2 pi is. So my answer would be 9 pi quarters. And here, if I add 8 pi quarters, it'll be 5 plus 8. That's 13 pi quarters. So my 4 answers from 0 to 4 pi are right here. That's my solution. Now, I probably should tell you solutions are often written in solution sets. So, like you would have this squiggly solution set, theta, such as theta is equal to blah, blah, blah. But for right now, it's important for you to be able to come up with these angle measures. We'll worry about solution sets and different things when I come back. So we're going to stop here. I'm going to take a look at your textbook, and we're going to pick out some questions for you and have you carry on with your day. So here's your assignment, page 211, questions 1 to 5, A, C, and E only. Try it out. If you get stuck somewhere, we will talk about it when I come back. Good luck.